This video will take a little bit of time to introduce the trigonometric ratios. So you very well could have been introduced to these in a geometry lesson that scratched on the surface of some trigonometry, but this is definitely kind of foundation for what you're going to be doing in a lot of the trig work throughout your trig course. So the three main trigonometric ratios are the ratios for sine, cosine, and tangent. These ratios always have to specify an angle that we're determining the ratio for. We'll talk about the significance of that angle in just a minute or two. There is definitely an abbreviation for sine, cosine, and tangent. The first three letters of each of those three ratios would be the appropriate abbreviation. Now, you wouldn't want to read this as sin, cos, or tan, right? Just read out the name of the trig function: sine of theta, cosine of theta, tangent of theta. I guess maybe this variable theta is something that might be new to you if you are just being introduced to trigonometry at the current time. Theta in math is oftentimes the variable that we use to represent an unknown angle. It's not wrong to use x or to use some other letter, but most frequently we're going to use the Greek letter theta. So the definition for sine of theta is going to be to take the side that's opposite the angle theta and divide that by the hypotenuse of a right triangle. For cosine of the angle theta, we're going to take the side adjacent to the angle theta and divide by the hypotenuse. And for tangent of the angle theta, we're going to take the side opposite the angle theta and divide by the side adjacent to the angle theta. So the reason why these are called ratios, you'll see that each of them, by definition, is a fraction or a ratio. And by definition, sine, cosine, and tangent refer to a specific formation of a ratio from the sides of a right triangle. And I guess that's something else that's important to point out. I don't know if I've really said this yet, but you can see from this diagram over here, and hopefully also by the fact that you see hypotenuse being used in some of these definitions, these ideas apply only to right triangles. So there's some tricks that you can eventually do to allow you to do some work involving these ratios with non-right triangles, but that's definitely a little further off in the distance. So when you're computing trigonometric ratios, you're only going to be able to apply them to right triangles. So a right triangle obviously has a right angle within it. What you see labeled within this triangle is the angle theta in the lower right. So whenever I compute the sine of the angle theta, I'm looking at the angle theta. I need to figure out which side is opposite the angle theta. So the side that's opposite the angle theta is going to be on the other side of that triangle. And then I need to divide by the hypotenuse. Well, from the work you've done with the Pythagorean theorem, you know the hypotenuse is the biggest side of a right triangle. It's always across from the right angle. So I would take the length of this side and divide by the length of the hypotenuse if I was computing sine of theta. For cosine of theta, I'm going to, again, locate the angle theta, which sits in the lower right-hand corner of this particular triangle. I'm going to be taking the side adjacent to the angle theta. So adjacent means along or next to. Now, there are two sides that are along or next to the angle theta. The side across the bottom here, and then the side that's working diagonally. Here's the thing you have to realize. One of these two sides that forms that angle theta, one of these two sides that's along that angle or adjacent to that angle is also the hypotenuse. So the side that's the hypotenuse is never going to be the side that's adjacent. So you might hear me say, you might hear some of your other teachers or professors say, you're going to take the adjacent leg. If you remember, the names of these two sides of a right triangle are called the legs. And then the third side, the biggest side, is the hypotenuse. So it's the adjacent leg divided by the hypotenuse when we compute cosine of the angle. And then for tangent, we're going to take the side that's opposite and divide by the side that's adjacent. Now, this right here is something that if you were introduced to this in a geometry course, something that you've probably done some work with. Sohcahtoa is just a nice little way, if you remember the spelling of this, it's a nice way to remember all of these definitions without having to literally memorize what's listed right here. So SOH, the first syllable of Sohcahtoa, sine is equal to opposite divided by hypotenuse. Cosine is equal to adjacent divided by hypotenuse for that next syllable. And then the final syllable, tangent, is equal to opposite divided by adjacent. If you mess up the spelling of this, this is useless. If you don't keep the order correct, it's useless then. So sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse, and tangent is opposite divided by adjacent. So we'll go ahead and do one example, and then we'll close this video out. So here's an example that asks us to find the values of sine, cosine, and tangent for angle B. So you'll notice how I'm using my notation here. I haven't written out the whole word sine. I'm using the abbreviation. Now, I never just want to write SIN equals. It's always got to be sine of an angle. Now, in this case, we're not using the angle theta. We're using the angle B. So you see the angle B is in the upper right-hand corner of that triangle. So think about what sine is. Well, if you spell out that word Sohcahtoa, SOH is the first syllable. Sine of the angle B is going to be the opposite side, right? Sine of the angle is equal to opposite divided by hypotenuse. So opposite the angle B, we have 18. Hypotenuse, we have 33. 18 divided by 33 is going to be the sine for angle B. What about cosine of angle B? Now you'll notice that when you do cosine, you have to do adjacent divided by hypotenuse, right? CAH is the middle syllable from Sohcahtoa. So cosine is adjacent. Well, I've already got that labeled, but you can see that I've written that in. That's not something that I knew from the onset here. So I need to take the measure of this side, the adjacent leg to angle B, and I need to divide by the hypotenuse in order to determine cosine of that angle. So the hypotenuse we already know. So we know we're going to be dividing by 33. What about the adjacent leg? Well, if you have a situation like we're faced with right here, you're missing one of the three sides of the right triangle. It is a right triangle, so the Pythagorean theorem applies. So if you do the old a squared plus b squared equals c squared, now I used x rather than b squared. So I did 18 squared, right leg squared, plus the other leg squared, the leg that we don't know squared. That's got to equal the hypotenuse squared. I want to solve that for x. So I'm going to subtract 18 squared from 33 squared. I'm then going to undo the exponent of 2, the squaring of the x by taking a square root. If you break out the calculator, 33 squared minus 18 squared is 765. Square root of 765 is an irrational value. I left it in exact form here. I left it as the square root of 765. You'll have to kind of pay attention to what your teacher, your professor is asking of you whenever you're doing stuff similar to what we're doing within this example right now. But for our purposes, I can just take the square root of 765, write the adjacent leg now that we've determined the length of it, and divide by the hypotenuse. And then when we go for tangent of angle B, what I'm going to end up with is I'm going to end up with, think about that last syllable, TOA, from that Sohcahtoa word, right? TOA. So tangent is equal to opposite divided by adjacent. So find the angle that you're trying to do this ratio for. Once again, it's angle B. That angle hasn't changed throughout this entire example. So when I do tangent of angle B, I'm going to have to try to take opposite, which is 18, and divide by adjacent leg, which is square root of 765. So opposite's on the other side, adjacent is along and is not the hypotenuse. Now this answer right here, I would accept that in my class. If your teacher or professor is asking you for a simplified answer, a lot of the time you're going to say that you don't want to have a root in the denominator, so you might have to find a way to rationalize this. For our purposes, this is fine to leave the answer like this when we're just kind of beginning to do some of the examples involving the trigonometric ratios. If your teacher is allowing you to use a calculator, you could type this into the calculator and you can round it off to the appropriate number of digits that your teacher is asking you to round off to. But hopefully that's given you a little bit of a feel for how to do this, how to compute these trigonometric ratios for an angle that's specified within a right triangle. A couple key points before we close this out. SIN, COS, TAN, those refer to the three main trigonometric ratios. They mean absolutely nothing unless there's an angle that you're computing them for. If I was doing the sine, the cosine, and the tangent of A, I'm going to still use these three numbers along the outside edges of this triangle, but I'm not going to have the same fractions being formed. So you never want to have just SIN equals, COS equals. It's always got to reference the angle that you're applying these calculations to. So that's something that I see overlooked a decent amount when people are first starting with their trigonometric work. So it's got to always be sine of an angle, cosine of an angle, tangent of an angle. The angle is the angle that you look at to determine opposite, adjacent, and hypotenuse. Those things change when you go to a different angle, which is why the angle is significant.